Software quality assurance, or SQA, is critical in today's technology-driven world. It's about ensuring software is developed and maintained to meet high-quality standards. But SQA is more than just finding bugs. It's about preventing them. It involves a set of systematic processes and activities throughout the software development lifecycle. SQA focuses on early detection and prevention of defects, aiming to deliver a reliable, functional, and secure software product. Effective SQA practices lead to improved customer satisfaction, reduced development costs, and enhanced brand reputation. Imagine a banking app that crashes every time you try to transfer money, or a social media platform riddled with security vulnerabilities. These scenarios highlight the importance of SQA. By adhering to SQA principles, organizations can avoid costly errors and deliver superior software products. In essence, SQA is about building quality into software from the ground up. It's a collaborative effort involving developers, testers, and other stakeholders. By embracing SQA principles, organizations can create software that meets user needs and exceeds expectations. Early testing is a fundamental principle of SQA. It involves integrating testing activities from the initial stages of software development. The goal is to identify and address defects as early as possible in the development lifecycle. This approach leads to significant cost savings and reduces time to market. Defects found in later stages are more expensive to fix. Early testing helps prevent defects from propagating to later stages, saving time and resources. By involving testers from the beginning, potential issues can be identified during the design and coding phases. Consider a scenario where a design flaw is discovered late in the development cycle. Fixing this flaw might necessitate significant code changes, impacting other parts of the application. Early testing could have caught this flaw during the design phase, preventing costly rework. Early testing also fosters better communication between developers and testers. When testers are involved early on, they gain a deeper understanding of the software's requirements and design. This shared understanding leads to more effective testing and reduces the likelihood of misunderstandings. Comprehensive test planning is crucial for effective software testing. A well-defined test plan acts as a roadmap, guiding the testing process. It outlines the testing scope, objectives, strategies, and resources. A comprehensive test plan ensures that all aspects of the software are thoroughly tested. The test plan should include details about the testing environment, test data, and test cases. It should also define roles and responsibilities within the testing team. A well-structured test plan helps in estimating the testing effort and tracking progress. For instance, a test plan for an e-commerce website should cover functional testing, performance testing, security testing, and usability testing. It should specify the browsers and devices to be tested, the expected load on the website, and the security vulnerabilities to be addressed. A comprehensive test plan serves as a communication tool for stakeholders. It provides transparency into the testing process, allowing stakeholders to understand the testing coverage and progress. This shared understanding helps in managing expectations and ensuring alignment between the development and testing teams. Test execution is the process of putting the test plan into action. It involves systematically running the test cases defined in the test plan. The goal is to uncover defects and ensure that the software meets the specified requirements. Effective test execution requires attention to detail and meticulous documentation. Testers need to follow the test cases precisely and document the results accurately. Any deviations from the expected behavior should be reported as defects. Clear and concise defect reports are essential for developers to understand and fix the issues. During test execution, it's crucial to maintain a consistent testing environment. This includes using the same hardware, software, and data configurations as defined in the test plan. Inconsistencies in the testing environment can lead to false positives or false negatives, impacting the reliability of the test results. Test execution should not be limited to functional testing. It should also include non-functional testing, such as performance testing, security testing, and usability testing. A holistic approach to test execution ensures that the software is tested from all angles. Principle 4. Defect reporting and tracking, identifying and resolving issues. Defect reporting and tracking are essential aspects of SQA. When a defect is found during testing, it's crucial to report it accurately and track its progress until resolution. Effective defect reporting helps developers understand and fix the issue promptly. A good defect report should include a clear description of the defect, steps to reproduce it, and the expected behavior. It should also include information about the testing environment, such as the browser version and operating system. Screenshots or videos can be helpful in illustrating the issue. Once a defect is reported, it needs to be tracked through its life cycle. This involves assigning it to the appropriate developer, prioritizing it based on severity, and monitoring its status. Defect tracking tools can help streamline this process. Effective defect reporting and tracking help in identifying recurring defects and patterns. This information can be used to improve the development process and prevent similar defects from occurring in the future. It also provides valuable insights into the quality of the software. Principle 5. Automation in testing. Increasing efficiency and coverage. Automation in testing is becoming increasingly important in today's fast-paced software development environments. Test automation involves using software tools to execute test cases automatically. This frees up testers to focus on more complex and exploratory testing tasks. Automated tests can be run repeatedly, ensuring consistency and reducing the risk of human error. They can also be run overnight or during off-peak hours, accelerating the testing process. Automation is particularly beneficial for regression testing, where the same tests need to be run after code changes. However, not all tests are suitable for automation. Tests that require human judgment, such as usability testing, are best performed manually. It's important to strike a balance between automated and manual testing to maximize efficiency and effectiveness. When implementing test automation, it's crucial to choose the right tools and frameworks. The selected tools should integrate well with the existing development and testing environment. They should also be easy to use and maintain. Principle 6. Performance testing, ensuring software responsiveness. Performance testing is a critical aspect of SQA, especially for applications that handle large volumes of data or users. It involves evaluating the software's responsiveness, stability, and scalability under different load conditions. The goal is to identify performance bottlenecks and ensure a smooth user experience. Performance testing can involve various types of tests, such as load testing, stress testing, and endurance testing. Load testing simulates a realistic number of users accessing the application concurrently. Stress testing pushes the application beyond its limits to identify breaking points. Endurance testing evaluates the application's performance over an extended period. For example, an e-commerce website needs to handle a surge in traffic during peak shopping seasons. Performance testing can help identify bottlenecks in the website's infrastructure or code, allowing developers to optimize performance before these peak periods. By conducting performance testing early in the development cycle, organizations can avoid costly performance issues after release. It helps ensure that the software can handle the expected load and provides a positive user experience. Principle 7. Security testing, safeguarding user data and privacy. Security testing is paramount in today's digital landscape, where data breaches and cyber attacks are becoming increasingly common. It involves identifying vulnerabilities in the software that could be exploited by attackers. The goal is to protect user data and ensure the confidentiality, integrity, and availability of the software. Security testing should cover various aspects, including authentication, authorization, data encryption, and input validation. It's crucial to test for common vulnerabilities, such as SQL injection, cross-site scripting, XSS, and cross-site request forgery, CSRF. For instance, a banking application should be tested for vulnerabilities that could allow attackers to gain unauthorized access to user accounts or financial data. Security testing can help identify and mitigate these vulnerabilities, protecting both the users and the organization. Security testing should be an ongoing process, as new vulnerabilities are discovered constantly. Organizations need to stay up to date with the latest security threats and best practices to ensure the ongoing security of their software. Principle 8. Usability testing, enhancing user experience. Usability testing focuses on evaluating the software's ease of use and user-friendliness. It involves observing real users interacting with the software and gathering feedback on their experience. The goal is to identify any usability issues and improve the overall user experience. Usability testing can be conducted using various methods, such as think-aloud protocols, eye tracking, and heuristic evaluations. Think-aloud protocols involve asking users to verbalize their thoughts while using the software. Eye tracking monitors users' eye movements to understand their attention and behavior. Heuristic evaluations involve experts evaluating the software against established usability principles. For example, a mobile app designed for ordering food should be tested for its ease of navigation, clarity of information, and overall user-friendliness. Usability testing can help identify any confusing or frustrating aspects of the app, allowing designers to make improvements. By conducting usability testing early and iteratively, organizations can ensure that their software is intuitive and enjoyable to use. This leads to increased user satisfaction, improved adoption rates, and reduced support costs. Principle 9. Continuous improvement, evolving testing practices. Continuous improvement is an essential aspect of SQA. The software development landscape is constantly evolving, with new technologies, methodologies, and threats emerging regularly. To stay ahead of the curve, organizations need to continuously improve their testing practices. This involves regularly reviewing and updating testing processes, tools, and techniques. It also means staying abreast of industry best practices and incorporating them into the testing strategy. Continuous improvement ensures that the testing process remains effective and efficient. One way to foster continuous improvement is to encourage feedback from the testing team and other stakeholders. Regular retrospectives can help identify areas for improvement in the testing process. Organizations can also leverage data and metrics to track testing effectiveness and identify areas for optimization. By embracing a culture of continuous improvement, organizations can ensure that their testing practices remain relevant and effective. This leads to higher quality software, reduced time to market, and improved customer satisfaction. Conclusion: the synergy of SQA principles. The principles of SQA are interconnected, working together to create a robust framework for ensuring software quality. By embracing these principles, organizations can establish a culture of quality throughout the software development lifecycle. Early testing helps identify defects early on, reducing the cost of fixing them later. Comprehensive test planning provides a roadmap for the testing process, ensuring that all aspects of the software are thoroughly tested. Effective defect reporting and tracking help resolve issues promptly and identify areas for improvement. Automation in testing increases efficiency and coverage, while performance testing ensures that the software can handle the expected load. Security testing protects user data and privacy, while usability testing enhances the user experience. Continuous improvement keeps the testing process relevant and effective in the face of evolving technologies and threats. When these principles are applied in synergy, they create a powerful force for delivering high-quality software that meets user needs and exceeds expectations. SQA is not just about finding bugs. It's about building quality into software from the ground up, ensuring a positive user experience, and protecting the organization's reputation.